you're going to be able to solve exponential equations. Okay. Exponential equations. Okay, good. Again, there's no need to be talking over top of me right now. Okay, exponential equations are equations in which the variable expression is in the exponent. So what we're going to do is we're going to start solving those. Okay, these types of problems can vary extremely from very, very basic to quite complicated. The most complicated you're not going to see until you're in Algebra 2. Okay, but we are going to have some that are going to require a little extra effort and work. Okay, you guys done? Okay. Okay, we're going to start with the most basic though. Here's the thing that's really nice. If you can get these equations in the same base, it's going to be pretty easy. So if I have 2 to the x power is equal to 2 to the 5th power, it's really easy because the bases are the same. Since the bases are the same, the exponents would have to be the same. So in this situation, if 2 to the x power is equal to 2 to the 5th power, then x is going to have to equal 5. And if x equals 5, then 2 to the x power is the same as 2 to the 5th power. That's the basic concept we're going to work off to start. So let's go to some examples. 3 to the x plus 1 is equal to 3 to the 5th. Are the bases the same? Since the bases are the same, the exponents are going to be the same also. So that means x plus 1 is going to be equal to 5. Okay, how do I solve for x? So in this situation, x is equal to, I almost wrote 5, but it's 4. So x is equal to 4. Okay, so when the bases are the same, the exponents are going to be the same also. Okay, 1b. 6 is equal to 6 to the 2x minus 3 power. Okay, are the bases the same? They are. So the exponents have to be the same. So I know 2x minus 3 is going to be equal to what? No. What exponent's there if there's no 1? So this would be 1 is equal to 2x minus 3. So now I need to start solving for x. Okay. The x is already on the right side, so I want to get rid of constant values on the right side. So I'm going to get rid of minus 3 with plus 3. 1 plus 3 is 4. And then divide by 2. X is going to be equal to 2. Questions about 1b? Okay, 1c. 10 to the 3x power is equal to 10 to the 2x plus 3 power. Base is the same? Are the bases the same?
Yes.
Yeah, so then if the bases are the same, that means the exponents are going to be the same also. So then 3x is equal to 2x plus 3, right? These ones you're just going to set the exponents equal to each other because the bases are the same. So now I just need to solve for x. Okay, problem like this. I have x on both sides. Okay. Since I have x's on both sides, to me, it might be most beneficial for me to undo the positive 2x. How do I undo positive 2x? Minus 2x. So now I'm left with 1x is equal to 3, and that's my answer. Okay. So we're going to, like I said, we're going to start out pretty easy. Problems will get a little bit harder as we go. Okay, questions? Okay, monitoring progress 1 through 3 is all yours. Go ahead and take a shot at it. I'll give you a little bit more time to work, but you can start looking over. So on 1, 2x is equal to 6 because the bases are the same. That means the exponents are the same. 2x means 2 multiplied by x. I undo multiplying by dividing. 6 divided by 2 is 3. Okay, now this one, 2x is equal to x plus 1. I got x's on both sides. Since the only thing I have on the left side is x's, I'm going to minus an x from both sides. 2x minus x is 1x. And then all that's left there is 1. Okay, on 3, I have 3x plus 5 is equal to x plus 1. I need to get all my x's on one side, so I chose to get them on the left. So I minus an x on both sides to get a 2x. Then I minus 5 on both sides to get a negative 4 on the right, and then divide by 2 to get x is negative 2. All right, any questions? All right. That is what I would call the easiest level of problems we're going to have. Okay, let's go to the next page. It's only 2 pages, so I'm wondering how far. I think we'll get done, but I can see you guys still struggle a little bit. All right, ready? Let's do 2A. What's the issue? Well, it's not the same. The bases, unlike bases, this is what you need to do. The bases are not the same. You are going to need to identify a base that you can rewrite them as being the same base. So I have 5 and 125. Those bases are not the same. So I can't just say that exponents are equal to each other. So rather what I need to do is I need to identify a base that I can rewrite it so it's the same. For example, well, 5 is just 5 to the first power. So what I'm curious about is, can I rewrite 125 as 5 to some power? Because if I can, then I can say the exponents are equal to each other. So what I'm going to do is I'm going to take my little cheat sheet out. Okay, I'm going to identify 5 as a base or a root. And I'm going to ask myself, can I rewrite 5 to some power and it's the same as 125? Yeah, so I know that 5 to the third power is 125. So knowing that, I can actually say 5 to the x power is equal to, instead of 125, what can I write? 5 to the third power. Now are the bases the same? They are. Since it's the same power, or the same base, the exponents have to be the same. So what can I write? My exponents are equal to each other. So in this situation, just x is equal to 3, and I'm done. They have to be in the same base for you to just say that exponents are equal to each other. Okay. 2b, are those bases the same?
No.
No. Does anybody think they know a base that they can get both of these into? 8. Okay, so if I'm going to go 8, 2 to what power is 8, or 8 to what power is 2? None. Well, 8 to the 1/3 power is 2, but I don't think you want to deal with fractions if you don't want to. Don't have to. So what base could I get both of these into? 4. I could do 2. 2 is a little bit better. Typically, if you're able to, the smaller of the 2 tends to be just a little more convenient. So the question is, if I want to try to get it to a base of 2, this base is already done, the right one. But what about the left one? Can I rewrite 4 as a base of 2? Yes, I can. 2 to what power is 4? The second. So instead of 4, what can I write? And now you're going to have to start remembering some of those exponent properties. Because I can rewrite 4 as 2 to the second power. But now I have 2 to the second power to the x power. What do I do when I have a power raised to a second power? What do I do with the exponents? Multiply. So actually, 2 times x is 2x. So this is 2 to the 2x power is equal to 2 to the x minus 3. Remember, power to power, you want to multiply your exponents. 2 times x is 2x. Are the bases the same now?
Yes.
Yes, since the bases are the same, I can say that the exponents are the same. What would I do to solve this one? Is there one side that has all my x's on it? No, I have one side that has more than one x here. Or doesn't have more than one x, has x's and constants, variables and constants. So here, x is -3. Okay. Questions about 2b? Okay, when we're talking about this is a little bit more complicated. This is the easiest of the three. This is the medium of the three. This one's going to be probably the hardest of these three that I'm looking at. So now I have 9 to the x plus 2 power is equal to 27 to the x power. Well, can I say 9 to some power is 27? No, because if you look at your sheet, 9, it goes right past 27. It goes straight to 81, so that's not going to work. So rather, I need to look at that number and say, is there a different base that I can rewrite both of them to be in the same base as? 27, so I'm going to check 20. Well, one, my thing doesn't even go to 27. But I can rewrite 9 as a base of 3. And can I rewrite 27 as a base of 3? So I'm going to want to rewrite both of these as 3 to some power. Okay, so here, 9 is 3 to the second power to the x plus 2 power. And 27 is 3 to the third power to the x power. Because 3 to the second is 9, 3 to the third is 27. Power to power, what do I do? Multiply. So you got to be pretty careful here. This is going to be 3 to the 2 times x plus 2. That's a distributive property. And I have more problems than I normally have you do today as practice problems, like 14 of them. And, for me, I jump from here to here. If you're able to get that and understand that, that's fine. Okay. Are the bases the same now? Yes. Since the bases are the same, that means I can say the exponents are going to be the same also. So now I have 2 to the x plus 2 power is equal to 3x. This is what property again? Distributive, which is what math operation? Multiplication. I like hearing that people know this. That means we learned something in the first semester. What can I do here to solve for x? Subtract 2x from the left. If I do that from the left, then I have to do it on the right. So then I'm left with 4 is equal to x, which means x is equal to 4. Okay. So on this one here, a giveaway is once I knew I couldn't say 9 is a power, 9 to some power is 27, I started thinking about what numbers are divisible by each of those. 3 isn't an option. Okay, 9 is just a power of 3, 27 is a power of 3. So if you can't rewrite one as a power of the other, okay, what you need to do is find a common base that is, when you rewrite it as a power, you get each number. Okay. All right, let's take a little bit of time, 4, 5, and 6. Okay, really work through these. Do not just copy my work down. Try to work through them on your own because they get a little bit more complicated than this. What's it say in red up there? Power to power.
Yeah, to put the 3 to the second power. Do you have more of those?
Yeah. It's close. The only thing that you're missing here is if you only roll X, do 2X, do times 2X would be 4X. They're very, very close. Let me unfreeze it on here and then I'll. Because I'm gonna look at my sheet, go to root of 4. Go to root of 4 on your sheet. And you rewrite 4 to some power and get 8. No, 4 to some power. No. Okay, so knowing that, I have to think, okay, what base can I get the power to become 4? And that same base to some power is gonna get me to 8.
Go to the root base.
You're gonna have to start with the root.
Oh, okay.
Okay, let's go over these in more detail. Okay. Like I said, I told you I thought it was going to be a little bit harder, start out easy and a little bit more difficult. Hey, walking around, I thought everybody could do 4. 256, take your sheet. I'm going to ask myself, can 4 to some power be 256? Yes, 4 to the 4th power. So I rewrite 256 as 4 to the 4th power. So that means X is equal to 4. Okay, and 5. I know that I have a base of 3 and a base of 9. So I ask myself, can I rewrite 9 as 3 to some power? And I can. I go to my sheet. 3 to the second power is 9. Okay, so instead of 9, I'm writing 3 to the second power. Okay, here on the left, power to power. What do I do with my exponents? I wrote it in red. What do I do with my exponents? Multiply when I have a power to power. That's the exponent rule. So then I get 3 to the 4x is equal to 3 to the x minus 6. Now I need to solve for the exponents. 4x equals x minus 6. And then at that point, I'm hoping you can just solve. Okay, questions about 5. Okay, on 6. The first thing I'm going to ask myself is, can I say 4 to some power is 8? Well, not really. I mean, I probably could get there with fractions, but my guess is you all don't want to do that. Okay, so then what I'm going to say is, can't do that. So then obviously I'm not going to be able to go 8 to some power to get to 4. So rather what I want to do is I want to ask myself, what's a common base that I can take both numbers to? Okay, so I might have to scroll through some lines and find both of those numbers. So here, as I'm looking through all zeros, all ones, okay, here I got 4 and an 8. Right? So I can say 2 to the second power is 4, and 2 to the third power is 8. You know, the same thing I could have done up here. I needed to rewrite them as a common base. So what am I going to do? I'm going to look for a row that has 9 and 27 in it. Okay, just so happened to be it's the first two numbers, but it could be the first and the fourth. Okay, so I had to scroll through all zeros, all ones. No. Okay, oh, this one, 9 and 27. So then now I know what base to rewrite them in. Okay, realistically, probably going to help if you do have some pretty good background in your math facts, though. Okay, 2 to the second to the third x, or 3x, power to power, I multiply, 6x. 2 to the third to the x plus 1 power. Okay, power to power, I multiply. Okay, at this point, you set them equal to each other and solve. Okay, questions? Okay, I have a worksheet for you that has 14 problems on it that you're going to need to work through today before you even touch your learning targets, because like I said, not necessarily the easiest thing. Okay. Well, what do we do now when we have these fractions?
Try.
Okay, now you might cry, but you do have a way out of it. So you might just want to remember a little bit about negative exponents. For example, if I have 3 to the negative first power, anybody remember how I simplify it? Flip it, put it under 1, and make its exponent positive. So this is just 1/3. So 3 to the negative first is actually just 1/3. Okay. So now what I'm going to do is I'm going to look at 3a. And I have a half. Can anybody think of a base that I can write 1/2 to, or a base I can write 2 to be 1/2? 2 to what power is 1/2? All right, so think about what we just did here. 2 to what power is going to be 1/2? 2 to the negative first power. So I can rewrite 1/2 as 2 to the negative first power, the x power. Can I write 4 as a power of 2? Right, because I wrote 1/2 as a power of 2. Can I rewrite 2 as a power of 2? Or can I write 4 as a power of 2? Sorry. 2 to the second power. Power to power, what do I do? Multiply. So now I have 2 to the negative 1x is equal to 2 to the second. Are the bases the same? Yeah, so I can just say the exponents are equal to each other. All right. So now, let's consider this. Anybody remember how I simplify 5 to the negative third power? Put it on the bottom and that flipping it is put it on the bottom. But what do I do then also? Okay. What happens to the exponent when I put it underneath? Okay, and anybody know what 5 to the third power is? Not 25. 125. 5 times 5 is 25 times 5 again. Okay, so now. Okay, so now what we're going to do is we're going to look at this one in because the bases, man, they really just, they're not the same. So I have a 4 here. So the first thing I want to do is ask myself whether or not 1 over 64 can be rewritten as a power of 4. So really, I know it's going to be able to if 64 is a power of 4. If 64 is a power of 4, then that means 1 over 64 is going to be a power of 4. So I'm going to go through here. Is 64 a power of 4? Yes, it is. So what can I rewrite 1 over 64 as? 4 to what power? Not quite. 4 to the third power is 64. I don't want 64. I want 1 over 64. Negative third power. So notice what we're doing. Now, we're typically here and we're going to here. Now we're going from here back. Are the bases the same? So what can I do when they're the same? Then the exponents are the same, so I can set them equal to each other. Folks, this is not the section you want to be not paying attention in. It's going to be hard with me teaching it to you directly. It's going to be way worse if you're just off topic right now. Okay. Okay. Of the hardest type of problems, this is the easiest. This is the most in the middle. This one's going to be a little bit of the hardest. Okay. So questions about B and A first before we move to C. Okay. 36 and 216. Right off the bat, I know I'm not going to be able to write 36 to some power to get 216. So what I want to do is I'm going to have to start scrolling through some of my rows until I can find a base that has 216 and also 36 in it. 6, right? Right, as I'm looking through here, zeros, ones, no. Looking for 36. Okay, and it has 216 in it, so that's perfect. Okay, now, one thing that I'm going to point out is, a lot of times when I see a number like 36, my guess is most of you have a lot of your squares just naturally memorized, just by working with them a lot. So when I see 36, the first thing I think of is 6. Okay, so I can rewrite 36 as 6 to what power? 36, 6 to what power? To the second power. Okay, now 1 over 216. It's not 6 to the third because 6 to the third is 216. But the negative third will be correct there. So if you're going to write if your base or your number you have here is a fraction, it's going to be a number to a negative exponent. Yeah. All right, power to power, I multiply. Now that the bases are the same, What does that mean about the exponents?
That's-
They're going to be the same also. So that means I can set those exponents equal to each other. So here, distributive property, 2 times -3 is -6. 2 times 3 is 6. -3 times x is -3x. -3 times 1 is -3. Now this one, you get to pick what side you want your variables on. And it doesn't matter. You just get to pick what side do we want them on. Left, okay, if we want them on the left, that means I need to get rid of them on the right. How do I get rid of a -3x on the right? Okay, so now here I'm going to get rid of my +6 with a -6. So -3x equals -9. And, I'm doing a lot of this math in my head just because I have so much practice with it. But like -3 minus 6, if you're not confident in that, what am I going to suggest you use? Just use a calculator. Yep, there's nothing wrong with that. So in this situation, x is equal to 3. Okay. So everybody, how I understood, I wanted to rewrite the bases as 6. What did I do to figure out that 6 was going to be the base number?
that had these things.
Yep, I looked for the row that had 216 and 36 in it. Okay. Okay. Let's work through 7, 8, and 9, and then I need to try to inform you of a couple tricks that you might see on some of the practices. And then at that point, I'm going to give you a worksheet, the rare worksheet day in this class, that you are going to need to work through and get all 14 of them before you work on learning targets. Okay. Just so everybody knows, I'm going to unfreeze the screen, but I don't want you copying. I want you just continuing to work. Okay, I'm going to want you just to continue to work through your problems. Just don't blindly copy. You're not going to get better doing that. So that's just up for you. The roll that has 5 and 25 in it. Okay, so it's gonna, you're gonna rewrite them as powers of 5. 5 of what power is 1 over 25? Negative what? Negative 1 would be 1 over 5. Negative 2 would be 1 over 25. Yes. Positive, it's just gonna be the number that's on your sheet. If it's negative, it's gonna be 1 over whatever that is.
Oh, okay.
Are you on Zoom? No.
I have 2 things I need to go back with. So. All right, I do want to go over this now, so let's okay. So on number 7, I'm seeing a 1/3. So that right off the bat is telling me base of 3. Okay, let's quit talking over top of me. Okay, so I'm going to look for the row that has 3 and 27 in it. 3 and 27 is in it, has a power of 3 or a root of 3. So I can rewrite 1/3 as 3 to the negative first power, and I can rewrite 27 as 3 to the third. Okay, power to power, I multiply -1 times x minus 1. I distribute, -1 times x is negative x. -1 times -1 is positive 1. And then -1 from both sides to get 2. Divide by -1 to get -2. Okay, I know my base, my exponent's going to be negative if I'm basically turning it into a fraction or flipping it. Okay, 8. 8 is actually is not that bad. I have 1 over 25, and I know 5 to the second power is 25. So 5 to the negative second power is -25. So what do? I rewrite 1 over 25 as 5 to the negative second power. Then I can get my basis. X plus 3 equals -2, minus 3 from both sides. X is -5. Okay, 9. Now on 9, this one's a little bit more difficult because I might not know what base to use. I have a base of 1 over 27 and 9. Those aren't the same. So what I'm going to do is I'm going to look for the row that has 9 and 27 in it. Okay, that's a root of 3. So I can rewrite 1 over 27 as x to the negative third power. Because 3 to the third power is 27. So 3 to the negative third power is 1 over 27. And then 3 to the second power as 9. Power to power, I multiply. So in this situation, I have to distribute. And then you solve. Your solving may look different than mine, but this is what I have. Okay, so I'm going to give a couple people a second or two to finish writing this. And then on the bottom of your cheat sheet, okay, I got some stuff I want you to write.
We have it in. Yeah.
I want you to write these three things, or these three sets. Okay. This is on your cheat sheet. You're going to want to write this at the bottom. We didn't cover explicitly some problems that had things like this, but they can pop up, especially with IO assessments coming back up. It's not going to blow my mind if you have problems like this on here. So this will be nice that we have some fresh new content for you. These are things that are like, they're the same base, and they are. Okay. So you can rewrite 2/3 and 3/2 using exponents and given the same base. Okay. I know that negative exponent, what did you all tell me it does? It what? Negative exponents do what? Flips. Okay. So I can rewrite 2/3 and 3/2 as the same. Okay. I can rewrite 3/2 as 2/3 to the negative first power. Okay, so if I want to write 3/2 is the same as 2/3, so the bases are the same, I can just say 2/3 to the negative first power. Okay. I could also rewrite, so 2/3 to the negative first power is 3/2. Okay, the other option is I could actually write 3/2 to the negative first, and that would give me 2/3. Because they flip. Right? Negative exponents flip things. So. Okay. So now when I look at 8/9 and 64 over 81, this is a problem that I look at it. Well, 8 squared is 64, and 9 squared is 81. That means 8/9. I can just say 8/9 to the second power is 64 over 81. Because 8 squared over 9 squared, 8 squared is 64, 9 squared is 81. So if I need to rewrite these as the same base, I can rewrite this as 8 over 9 to the second power. Okay, and then I have 5/7 and 49 over 25. This one's weird because I know 5 to the second power is 25 and 7 to the second power is 49. So 5 over 7 to what power? Yeah, negative second. Because it's going to take it to the second power, but it's also going to flip it. So this would be negative second power. Because it flips, but it also is raising to the second power, so negative second power, okay? So those are some things you're going to see on the worksheet that are just, things that didn't get explicitly covered. So I'm giving you examples that are going to be on your cheat sheet. Okay? All right, I have a practice problem worksheet for you all. You got to complete that before you do your learning targets. Otherwise, that's it for the day.